One of the first lines of defense from accident is a level of redundancy to the processes in order to absolutely minimize the chance of an unplanned event. Though some features are not rated as being safety related, much of what could go wrong is effectively stopped at this stage. By integrating these systems into the processes of the reactor, a greater efficiency is achieved by providing shorter downtime from inspections. Some of the features include chemical and volume control systems, a residual heat removal system which is constantly working to maintain temperatures within the reactor, and an auxiliary feed water system for use during startup. Though none of these systems are unique to the AP1000 reactor, by maintaining a reliant system of checks and balances, the majority of dangers are caught too early on to become a problem. Now, for the passive safety-related systems. The first is the passive core cooling system. Now, this utilizes a passive convection as well as a pressurizer in order to maintain pressure in the lines in case of a break. After the pressure has exhausted its supply, water and then steam are used to maintain pressure. It has an 8 million pound water tank that gravity feeds the entire system. Here is a graphic that will show in a little bit more detail the processes of the passive cooling system. The next is the containment isolation. It's a simple enough idea that fission products wouldn't be able to reach fluid lines running through the reactor. In the case of an incident, through simple isolation of the lines, they can prevent contamination throughout the rest of the system. The next feature is the passive containment cooling system. Outside air and water are used to cool the top of the steel containment dome. Through the evaporation of the gravity-fed cooling lines and the effects of convection within the reactor containment, the core would remain cool enough as long as the cool tanks remain supplied. Their capacity is enough to last 72 hours, and connections are available for alternate sources as well. Main control room emergency habitability. The control room may be isolated. In the case of high airborne radiation levels, it is equipped with an air supply to accommodate 11 people for 72 hours. So even if something goes wrong, the control room will be able to remain isolated and safe for human habitation for up to 72 hours after the event.